Now we're looking at finding the volume of an oblique cylinder. And remember that Cavalieri's principle tells us that if we have an oblique cylinder, we solve that the same way that we solve a right cylinder. So if this was straight up and down, so that the base was perpendicular to the height, we would solve it the same way. And so in this case, again, our formula for volume is pi r squared times the height. So we need to know our radius, which is 4 centimeters. And we need to know our height, which is 7 centimeters. The height is not from here to here. It's straight up and down. So if they do happen to give you this, and then let's say they give you this distance right here, you would have to use Pythagorean theorem to find the height. Okay? We're going to plug everything in here. So we get pi times the radius, which is 4 squared, times 7. And if we do that, we get pi times 16 times 7. 16 times 7 gives us 112. So we get 112 pi. And if we get our calculator, 112 times pi to 2 decimal places, it would be 351.86 cubic centimeters. So again, Cavalieri's principle is what we talked about before. We use our formula, we plug everything in, we simplify, and we solve. Okay? Alright, so here's another problem. I'm going to do this slightly different from the way the book does it. They're telling us each of these beams right here are 30 by 30 by 90. So if you look at it, you're really only seeing 2 dimensions. The third dimension goes out here, 30 centimeters. So if I was to write just this figure right here, it would go something like that. And then it would go down and over, and I guess it would go something like that. Okay? So if I look at this, there's a couple ways we can do this. The way that I'm going to do it to find the volume of this whole thing is I'm going to take the volume of the whole thing, which I'll call volume 1, and then if you notice there's 1, 2, 3, 4 openings here. I'm going to subtract out 4 of those little openings. So it'll be something like that. So the first thing we want to do is find the first volume, which is the whole thing. And so we're going to have to find the base of the whole thing and the height of the whole thing. In this case, the base is 90 by 30. So we would say base 1 is 90 by 30, or 2700, and that would be square centimeters. The height here is the 510 centimeters. So we're going to end up multiplying 2700 times 510, which ends up being like a million something. Let's see, 510 times 2700. We get 1,377,000. And this time it's cubic centimeters. Now we're going to do volume 2, which is the volume of just one of these openings here. So we would say base 2 and height 2. And again, remember this is going back 30 and then up 90 and across 30 there. So the base for one of these openings, which I'm just going to draw real quick as if it was 3D. Would look something like that. It would be 30 by 30 would be the base. So 30 by 30 gives me 900 square centimeters. The height here is 90 centimeters. So we're going to plug in 900 and 90. and this gives us, oops, not 27, sorry, 81,000 cubic centimeters. And we want to know what 4 of those volumes are. So we're going to do 4 times 81,000. And we get 324,000. So again, what we're doing is 4 times 81,000. And that gives us 324,000 cubic centimeters. So here, what we're doing is we're figuring out 1,377,000 minus 324,000. And if we subtract those two, we end up with 1,053,000 cubic centimeters. And that would be the volume of all of these pieces here. A couple different ways we could do this. We could find the area of the whole face here, and then we could say that the height was 30. So we could find the area of this face right here. Similar to the way we found the area of the bases and all that. And then the third way we could do it is there's 13 beams. Each one is 30 by 30 by 90. So we could find the area of one of these beams and then multiply it by 30. But I did it the way you're going to do it most of the time. So the way they did it was they found the area of the whole front surface, and they did the area of a large rectangle minus 4 times the area of the small ones. So the area of the large rectangle was 90 by 510. The small rectangles were 30 by 90, and there were 4 of them. So the area of that front surface is 35,100. To find the volume, we would just take that area of the top surface times the height, which is 30, and then we'd get the same answer. Okay? Alright, this next one, again, an oblique prism. So Cavalieri's principle tells us we don't need to worry about it being slanted like this. We just take the height or the distance between the bases. So here our formula is area of the base times height. So we need to figure out the area of the base. If we look carefully, the base is a right triangle. So I'm going to draw that separately. And remember, the base and the height are always perpendicular to each other. So if this is 90 degrees here, and this is 9 meters, and this is 5 meters, the formula for area of a triangle is 1/2 base times height. This big base is area of the base. Small base is the length of the base. So here we would have 9 times 5. And I'm going to leave this as 45 over 2. So our height happens to be 8 meters. And this was 45 over 2 square meters. So we're going to multiply 45 over 2 times 8. A little bit easier than doing surface area. So 8 divided by 2 gives me 4, and if we multiply that out, we get 180 cubic meters. Okay? And there's our 180 cubic meters. Now we're going to figure out the volume of this solid. If you notice, we've got a triangular prism, and this right here is considered to be a hole, so we've cut that out. So basically what we want to do is figure out the volume for the whole thing and then subtract out this square prism. So let's figure out both volumes. For the first volume, we're going to do area of the base times the height for that base. And if we look carefully, this time the triangle, it's an equilateral triangle. You could use 1/2 AP, but there's actually an easier way to do it. So we're going to use that method. We know this is 10 feet, and if I draw a line going straight down, this ends up being 5 feet. And you notice this is 60 degrees because it's equilateral, therefore it's equiangular. That makes this a 30, 60, 90 triangle. And if that's 5 feet, this is 10 feet right here. And hopefully we know that this right here would be 5 rad 3 feet. Okay, so to find the area of the base, again, we're going to use 1/2 base times height. And the base here is 10. The height is 5 rad 3. I'm just going to simplify. You get a 5 there. This becomes 25 rad 3 square feet. Our height ends up being, and this is base 1 and height 1. Height is the distance between the bases, so it's not straight up and down. It's the distance between the bases. It's 6 feet. Okay? So in this case, it would be 25 rad 3 times 6, and that is 150 rad 3 cubic feet. Now we're going to figure out the second volume, so we need to figure out the second base and the second height. For the area of the base, much easier here because it's a square with sides of 3, so that gives me 3 squared, or 9 square feet. Again, the height is the same, it's 6 feet. So we're going to say 9 times 6, or 54 cubic feet. And now we just subtract the 2. So we're going to have, whoops, sorry, not 10, but 150 rad 3 minus 54. And this is where we get out our calculator. So we say 150 times rad 3, and we subtract out 54. We should have gotten 205.81 cubic feet. And we get 205.81. And we're done. Thanks.